this is the third video of our deep learning series. In past two videos, we have used artificial neural network for numerical data only. But today, we are taking a step further by working with image data. So although for image data, we use convolutional neural network, but to clear our concept, we will use artificial neural network for image data. In upcoming videos, we will also use CNN for that, and we will compare the results between these two and see that what are the differences and why we use CNN for image data. So the data set that we'll be using is one of the most famous data in machine learning and deep learning domain. The data is MNIST data. Let me show you there. This is what MNIST data looks like. So it contains 70,000 labeled images with of handwritten digits ranging between 0 to 9. So we have 10 classes here. We have 10 classes from 0 to 9, and we have 70,000 grayscale images. So before diving into the code, let's first understand that what is an image. So an image is essentially a NumPy array that contains continuous values between 0 to 255. So for grayscale images like MNIST, each pixel, these are the pixel values 0, 6, 8, 1, 1. These are the pixel values of images. 0 shows the black spot, and 255, the maximum value, shows the white spot. And all the numbers in between shows the gray or any other color. So in this video, we'll explore that how to process image data and feed it into artificial neural network. And by the end of this video, you will have a working model that can classify handwritten digits with impressive accuracy. So let's get started with the code. So we will follow the same architecture that we have followed in our previous videos. First, we will find the data, that is MNIST data, and then we will load the data. So we don't have to download this data from Kaggle. This is the inbuilt data in TensorSlow library. So let me directly download it, load it in Jupyter Notebook. So I've already imported all the necessary libraries that we are going to use for this model. So now for loading the MNIST data, we just have to write one line: xtrain ytrain xtest ytest equal to kras dot dataset dot MNIST not load data, and this will load our data. So now let's check that what is inside xtrain variable. So in xtrain we have 60,000 images. Let me check the shape. So in xtrain we have 60,000 images, and in xtest we have 10,000 images. So the size of every image is 28 by 28. Now let's check the first image. So this is the first image of our data set, and as you can see, these are the values, these are the pixel values which are showing the intensity of pixel in an image. Now let's check that what is in ytrain. So in ytrain we have corresponding labels of xtrain between 0 to 9. So in ytrain we have labels like 5, 0, 1, 4. In ytrain we have labels, 60,000 labels. And now let's check that how images are stored in this xtrain. So we can display or plot this image by matplotlib. So we will write plt dot imshow and pass the xtrain, pass the numpy array. So xtrain 0. So this is the first image of our dataset. Now let's check if ytrain has the same value for that or not. So ytrain has the label of xtrain. So now let's jump on to the next step, which is to split the data. So we have already splitted the data in xtrain and xtest. Now let's normalize the data. So to normalize the values, let me show you that what our pixel values are like. So in xtrain we have pixel values between 0 to 255. So to normalize these values, we just have to divide it by 255, the maximum value of a pixel. So we will store it in xtrain. So xtrain divided by 255, and we will do same with xtest. So xtest equal to xtest divided by 255. Now let's check what our scaled values are like. So these are the scaled values. As you can see, every pixel values is now in the range between 0 to 1. So we have scaled our value. Now it's time to define our model. So let's discuss our model architecture first. So this is our model architecture. We will flatten the image into a single array, a single dimensional array, and then we will pass these numbers into our input layer, and then in hidden layers, and then we will calculate the output. So the architecture will look like this. First we have a image of 28, then we will convert this image into a single dimensional array of 784 numbers, and then we will feed this into our hidden layer. So this will be our input layer. This will be our input layer of 784 neurons, and then we will pass this into our hidden layer. We will add two hidden layers, and then we will add output layer. So hidden, and then one more hidden, and after that we will add our output layer. So in output layer, how many number of neurons we have to insert? So in output layer we have to calculate the output, or we have to predict the class. So how many numbers of class we have in this data? We have 10 classes, 0, 1 to 9. So we have 10 classes. So this is a multi-class classification task. So we will use softmax for output layer, and after that we will compile the model and train our model. So let's get started with the code. So first make the object of sequential class, and in this class we will add our first layer, which is flatten layer. So we will directly append this flatten layer here, and the input shape of flatten layer will the input shape that our flatten layer will expect is 28 by 28. So input shape of this flatten layer will be equal to 28 comma 28. Now we will add dense layer with 128 neurons, and activation function ReLU activation equal to ReLU, and we will add our second hidden layer with 64 neurons with again activation function ReLU, and then we will add our output layer with 10 neurons, and activation function will be softmax because it is multi-class classification task. So this is our model. Now let's check the summary of model. So we will write model.summary, and this is the summary of model. So in first layer we have 784 neurons, which is input layer. We are basically converting 28 by 28 image into single dimensional 784 array, and then we will pass this array into our first hidden layer, which is this with 128 neurons, and these are the trainable parameters. And then we have 64 neurons with these numbers of parameters, and then we have our output layer with 10 neurons and 650 parameters, and with softmax because this is multi-class classification task. Now let's compile the model. So model dot compile, and at loss function, loss we will use sparse categorical cross entropy for multi-class classification, and Adam optimizer as Adam, and matrix accuracy. After compiling, let's start the training of model. So model dot fit, and here we will pass our data xstring, comma labels ytrain, and number of epochs will be 25 here. Let's take 30 epochs, and validation will be split will be 0.5 epochs. So the training has started. Now let's wait until this get trained. So this is the accuracy after fifth epoch. I've changed the number of epoch because it was converging very frequently. So this is the accuracy. As you can see, we got 99% accuracy and 97% validation accuracy. So now it's time for evaluation. So we will evaluate it on our test data. So model dot evaluate, and we will pass our x test here and y test. So this is our accuracy 97%, and this is the loss. So now let's make the predictions on our data. So model.predict will pass x test here. So this will and we will store predictions in ypred. Now if we will check the first digit of x test, plt.imshow, this is the first digit of our x test data. Now let's check that what our model is saying. So to check that, we have to check the first value of ypred, and from that we have to check the maximum value of the class, which class holds the maximum probability. So 0, 1, 2, 3, 4, 5, 6, and 7. 7 hold the maximum probability with 9. So this is the correct prediction. So let's predict on one more image. So we will see that what is the second image in X test. So the second image in X test is 2. Now let's predict. So model dot predict model.predict x test first, and we will find the maximum value of. We have to check on y predict. So we have stored all the prediction in y predict. So we will check y pred first prediction dot argmax. So we have two here. So now let's check for the third image. So we okay. So we have to pass 5 here. So in fifth place we have 1. Now check in what we have in fifth place. So in fifth place we have 1, and now let's check what is on ninth place. So in ninth place we have 9, and now let's check what our model is saying. So our model is predicting everything correctly because we have obviously we have 99% accuracy. So yeah, our model is performing perfectly, and the accuracy is very high. So this is how you use artificial neural network for image classification tasks. So that's it for the video, guys. In next video we will see how to use convolutional neural network for image classification tasks. Stay tuned.